Dear student, welcome to my channel. Topic of this video is classical cryptography, and in this video I am going to explain the transposition method. Now let us start. Transposition technique. A transposition cipher is a cryptographic technique where the plain text letters remain the same but their positions are rearranged according to specific rule or pattern. Unlike substitution ciphers which replace the letters, the transposition ciphers alters the order of letter to obscure the original message. Example are rail fence, columnar, root, double transposition cipher, etc. Now in transposition cipher there are two techniques are there. One is keyed and keyless transposition cipher. Now keyed transposition cipher, as its name indicate, it uses a key to determine the rearrangement of the plain text. The key provides a specific rule for ordering rows or columns and adding complexity to the cipher. Example is columnar transposition cipher where columns are arranged based on a key. Now the next is keyless transposition cipher where it does not have any key. The rearrangement follows a fixed predictable pattern which is shared between sender and receiver already. Example is a rail fence cipher which writes a text in zigzag pattern without needing a key. Both methods rearrange the letters but differ in their dependency on key for encryption and decryption. Now first we will see the example for a keyless transposition. So first example is rail fence cipher. The simplest such cipher is the rail fence technique in which plain text is written down as sequence of diagonals and then read off as a sequence of rows. So when we arrange this text it will looks like a rail fence. Now for example the text is meet me after the party is over. So here between sender and receiver that particular is fixed that they are going to use only the two rows. The number of columns based on our input plain text but number of rows are fixed. So M will come here, ET meet, then ME meet, AFTER after the party. So we are arranging like this, and when we are sending like this, the first row and the second row. So when we are sending the cipher text, we are sending the cipher text like this. Now at the decryption side, the number of rows are fixed and number of columns are depends on our number of cipher text character. For example, if cipher text contains n characters and if n is even, then n by 2 columns are there, and if n is odd, then n by 2 plus 1 columns are there. So based on this length of the cipher text, our columns are get converted, that is into particular number of columns, and we are arranging the text, and in this way decryption is possible without a key. Next we will see the route cipher. So variety type of techniques are there. So route cipher in which the spiral method is used. So in this here the grid is fixed, that is for example 4 columns are fixed. So this is communicated between the sender and receiver. So now see, the word is there, hello world. So for simplicity we skip the space. Now during the encryption we will write HELLOWORLD, that is we are following same the order, first row complete, then second row complete, then third row complete. So here we can use the filler also, that is XX. Here we can use the filler also, XX. Now here the columns are fixed. So at the encryption time, first we arrange by row wise, then at the time of encryption we are using the spiral order. So HELLROWOLD is sent as a cipher text, and at the receiver side we require to do exactly the opposite thing, because at the receiver side we know 4 columns are there. So we are writing in a spiral way first, and then we read in a row by row, so we will get the original text. Next we will see the keyed transposition cipher in which key is used. Example is columnar transposition cipher. So for example, take example here, key is super. Now here in super we will give this as the first column because E comes alphabetically first, then P will come, then R will come, then S will come and U will come. So see, this is a keyword super, and we are giving the column order. So this is the first order, second, third and fourth and fifth. When our text comes, so here our columns are fixed because our keyword is of 5 character. So this is a plain text. Okay, so when it comes, then at that time we will first write down arrange in a row by row. This is a plain text. Okay, now here we can use the filler also, that is XX. I have used space, but it is better to use the space. Now here after this we are sending the data in encrypted form. So this is the first column, so we are sending first this SLA, then we will send this, then we will send this. In this way we are sending the data. So this is nothing but the ciphertext SLE space, then next is IPTK, and then next third is IAX dash, then TSATHNO. And at the decryption, what we require to do, at the decryption our number of columns are again fixed, only number of rows are changed. So for example, if 40 characters are there, 40 by 5, so 8 rows are there. So based on that number of characters we can find out the number of rows, and we require to arrange the data. So at the receiver side also super keyword is there, we will write down these things, and whenever this data comes, so first we will decide the number of rows. So if 8 rows are there, so we will pick up 8 character and we will put here. So in this way decryption can be possible. Another way is to arrange that we can use the particular order at the encryption and decryption. This is used in a symmetric cipher, that is DES, data encryption standard. So here we are using a particular order at encryption and decryption. Now here 5 columns are there, so whatever input text is divided into chunk of 5. So for example, text is anyway attacks tonight, we will divide this text into chunk of 5. So for example, here it is divided. Now we are using the order. Now here see, during the encryption what we are doing, input order is this and output is this. Now we'll see 1 2 3 4 5. So here whatever the input at third, it will come to the first location. So input third is E, it will come to the first location. Then next is the input at 1, it will come to the second location. Input at the 1 location is E, it will come here. Input at 4th, that is M, will come here. Input at 5th, that is Y, it will come here. So this order is kept during the encryption, and during the decryption the reverse order is used. Now here we are using columnar. We can use row wise also, we can use column use also, and we can use n number of orders. So when we are using the transposition technique for more than one time, it becomes complex for the attacker to understand the particular pattern. Now we'll see the difference between the substitution technique and transposition. It changes its identity but retain its position. It changes its position but retain its identity, because here only shuffling takes place and here the characters are substituted by another character. It is a simple process, it is complex. It is easy to crack the code, it is difficult to crack the code. Here unauthorized users can easily access the data, difficult for intruders to access information. Transposition techniques look simple, but when we apply the row wise and column wise transposition technique and n number of times, at that time they becomes difficult for the difficult to break. The time complexity of the encryption and decryption is less, but here it is more. Example are scissor cipher, Hill cipher, mono alphabetic, polyalphabetic, and here example are columnar, rail fence, and then next the words which are arranged in a different order, for example zigzag, spiral order. So all are nothing but the transposition techniques. So this is all about the both methods of transposition and substitution techniques. These are the references for the video. Thank you.